Okay, so next lesson. This is 6B. Uh, this is going to talk about right angles in geometry. Okay, the only thing we need to know for this lesson is that diagonals in polygons make right triangles. Okay, so we have different polygons, different figures, and when you draw the diagonals, it's going to make a right triangle. Now, that's important, that's good for us because we are now experts at right triangles, right? So, here's what I'm talking about. Here's a rectangle, right? Here's a rectangle. When you draw the rectangle and you draw a diagonal, it doesn't matter which way, this way or the other way. Look what you create. You create two right triangles. That's it. That's all I'm saying for today. When you draw a diagonal, you're going to create right triangles. Okay? Another shape. The square. Okay? The square is actually going to make, if you draw one diagonal, it's going to be exactly like the rectangle, but if you draw both diagonals, it actually makes many right triangles. Well, 4 right triangles, right? That's a right triangle, that's going to be a right triangle, that's going to be a right triangle, etc. Okay? That's all I'm saying today. When you draw a diagonal, it'll create right triangles. Look at this one. This is a rhombus. You remember the rhombus? So when you draw a diagonal this way, actually nothing happens. But if you draw both of them, then you do create, every single time, you do create right triangles. When you draw both diagonals, you'll create 4 right triangles. They happen to be all equal, but nevertheless, they are right triangles. Okay, another one? The isosceles triangle. Now, the isosceles triangle actually, this is well, you can't draw a diagonal because you can't go from corner to corner in a triangle. But if you drop what's called a altitude or a median in an isosceles triangle, you do in fact create right triangles. Okay? So all I'm saying here today is when you have different geometric figures and you draw the inside line or the diagonal, you create right triangles. So that we can use that to our advantage. So look at this example. Hold it. There we go. The longer side of a rectangle is 12 centimeters and its diagonal is 13 centimeters. Okay, we're talking about a rectangle and it's giving us this information. So from that information, you should be able to find the shorter side of the rectangle and the area of the rectangle. Okay, so how do we do this using right triangles? Well, if we draw what they're talking about in the problem, isn't this what we get? The longer side of a rectangle is 12, the diagonal is 13, find the shorter side. Hey, that's a right triangle. Do you see the right triangle? Right there. Why, we are experts at right triangles, so I quickly do x squared plus 12 squared is equal to 13 squared, right? And then subtract from both sides, and then do the square root, and I did it all in one shot, and I got x equals 5. Okay, so again, I did this really quick, but we all know how to find the missing side of a right triangle. This happens to be the missing side of a rectangle also, but we use the Pythagorean theorem to find the missing side of a right triangle. And that's what we're looking for. It happens to be the shorter side of the rectangle. So we're done. The shorter side of the rectangle is 5. Exactly 5, by the way. What about the area? Well, for the area, you're supposed to remember that the area of a rectangle is length times width. Now that I know the length and the width, no problem. The area is 5 times 12, which is 60. Done. Okay, the point of tonight's lesson is that we can use right triangles within geometric figures and then later find missing sides and areas. Okay? One small note here. You're supposed to remember many of the formulas. Do you remember the area of a triangle formula? Area of a triangle formula, it's half base height. Right? This is the base at the bottom here. The height is this line here, also called altitude. And do you remember the word perimeter? It means to add all the sides. Okay? This is all prior knowledge. Okay. One more example, and believe it or not, we'll be done. Again, all we're doing is using right triangles within geometric figures to find the answers. So now we have a rhombus. A rhombus has diagonals of 6 and 8, right? A rhombus has two diagonals, one is 6, one is 8. Find the length of the sides of the rhombus, right? Find the length of the sides of the rhombus. And then after you get done with that, you're able to find the area. So here is a diagram of what they're talking about. Here's my rhombus, right? A diagonal of 6. So one diagonal is 6, which means it's 3 and 3. And the other diagonal is 8. All the way across is 8, which means it's 4 and 4. Right? I can't put 6 because they cross each other, so I'm putting 3, 3. I can't put 8 because it's crossing each other, so I'm putting 4, 4. Okay? I got that from the information. Now, find the length of the sides. Well, if you look carefully, we have created right triangles. So this is the side of a right the hypothesis of a right triangle, but it's also the side of the rhombus. So all I need to do is find the hypotenuse, and I will have the side of the rhombus. Well, that looks easy. 3 squared plus 4 squared is equal to x squared. Right? Add them up, take the square root, and voila, the answer is 5. I found the side of the rhombus. 5. By the way, they're all 5, right? 5, 5, 5, 5, because all the triangles are the same. Okay. What about the area? Well, for the area, the easiest thing to do is to notice, that you're dealing with two triangles. This triangle with a base and a height, and this triangle with a base and a height. So why don't we find the area of one of the triangles and then double our answer, and we get the area of the rhombus. Okay? That's the plan. So the area of one of the triangles is 6 base, 4 height, right? And then the area is 12. Right? Now remember, that's the area of the triangle. The original question was find the area of the rhombus. So now you have to remember to double that. Right? So the triangle area is 12, but the rhombus area is double 12, which is 24. Done. Okay? That's it. So tomorrow's assignment will have different figures, and all you're going to do is draw in the diagonals and create right triangles to solve any question they ask. So here we go. This is what we did today. We talked about, here I'm flashing, so you can pause and copy here. So geometric figures, diagonals create right triangles. First example, a rectangle, the diagonal going through it makes the two right triangles, and you can find the missing side and the area. And then I reminded you of the area formula of the triangle. And then the last example was a rhombus, and we found the missing side of the rhombus by using one of the right triangles. And then we found the area by splitting it into two triangles, found the area of one triangle and doubled it. Okay, that's it. See you tomorrow. Good night.